In this video, we're going to talk about how to add and subtract vectors and how this can be used in our discussion of kinematics. So to start with, let's imagine that we have a truck and that truck is located 2 meters to the right and 5 meters above the origin. And we'll call this its initial point such that this position, the truck's position, is described by the vector r sub I. That is, to get to the truck, you would have to travel 2 meters in the x direction and 5 meters in the y direction. This means that we could write the vector r sub I mathematically as 2 meters I hat plus 5 meters j hat. Now, imagine that the truck drives to a different location over here at 1 meter in the y direction and 4 meters in the x direction. So in this case, we can draw our final vector, the vector pointing from the origin to the truck's final position here. And again, we can write our final as how far did we move in the x direction? So that would be 4 meters in the x direction. And then how far did we move in the y direction? 1 meter in the y direction. Such that we can write the vector r final. Now we can write the vector r final as 4 meters in the x direction, 4 meters I hat, plus 1 meter j hat. Now, what we might like to do is actually find the vector that connects these two. And I will call that delta r, my change in position vector. So this vector here, I'll call delta r. And just like we have always done, we can write delta r as the final vector, r final, minus our initial vector. Now, the thing that we need to think about here is how can we find delta r when we are moving in both the x and the y direction? So we're going to learn how to do this two ways. First, we're going to do it purely graphically. So if I look at the vector delta r, well, it starts at the point up here at 2 meters in the x direction, 5 meters in the y direction. And to get to my final position, I need to go down 4 meters. Because I started from 5, I ended at 1. I needed to go down 4 meters. And I needed to go 2 meters to the right, which makes me think that I should be able to write delta r as 2 meters I hat minus 4 meters j hat, where the negative sign indicates that I moved in the negative y direction. Now, that is called the graphical method of subtracting two vectors. You physically draw each of the vectors, and then you find the vector that points from your initial vector to your final vector. In general, this graphical approach to vectors is useful visually, but it is not the fastest way to add or subtract vectors. To do that, we're actually going to use an algebraic approach. So here I have rewritten my initial and final vectors. And if I physically write out delta r in terms of the two vectors, so it is r final minus r initial, so that is 4 meters I hat plus 1 meter j hat minus 2 meters I hat plus 5 meters j hat. And the key here is to realize that the x components, the I hat components, are independent of the y components. That is, moving in the y direction does not help you move in the x direction. Likewise, moving in the x direction does not help you move in the y direction. So if I want to move 3 meters in the y direction or 2 meters in the x direction, I can only do that by moving in the x direction. So using this idea of independence of x and y, I can rewrite this as 4 meters minus 2 meters in the I hat direction plus 1 meter minus 5 meters in the j hat direction. And you'll notice that this leads us to 2 meters I hat minus 4 meters j hat, just like we found with our graphical approach. So if you want to add vectors and you know the components of the vector, it's very easy to add or subtract vectors. This is one of the many reasons why having vectors in component form instead of magnitude and angle form is much easier to work with for physics. So whenever you have two vectors that you want to add or subtract, you can simply add and subtract the individual components together. As another example of adding or subtracting vectors, let's just take two arbitrary vectors. These are position vectors, but I'm not even going to bother drawing them. I can simply find out what their sum or difference is algebraically. So let's imagine that I have some other vector c, which is equal to a vector plus b vector. Well, c vector is therefore equal to 3 meters I hat minus 4 meters j hat plus negative 12 meters I hat plus 7 meters j hat. Adding like terms, so again I add the x things to x things and I add the y things to y things. I get negative 9 meters I hat plus 3 meters j hat. If I instead have some vector d, which is equal to the difference between a and b, well then I can say that it is going to be 3 meters I hat minus 4 meters j hat minus negative 12 meters I hat plus 7 meters j hat. And this will lead me to 15 meters I hat minus 11 meters j hat. As a final note, I just want to show you a quick way of adding vectors graphically. So we saw how to subtract vectors graphically, where you draw each of the two vectors and then you draw the difference, delta r, was the vector that points from your initial position vector to your final position vector. But if I want to add two vectors together, there's also a simple way of doing that graphically. So let's imagine that I have a vector A, which is 3 meters in the x direction and negative 4 meters in the y direction. So that means that it points from the origin to the point 3, negative 4, like this. And I want to add that vector to vector B. So the thing that I can do is I can draw A from the origin, and then I can draw vector B from the end of vector A. So what I can do is I can take vector B, which points negative 2 meters in the x direction, so it's going to go 2 meters this way, negative 1 meter in the y direction, so it's going to go 1 meter down. So this is vector B. And if I say that there is some vector C, which is equal to A plus B, then vector C will always point from the origin to the end of vector b. This is called the tip to tail method of adding vectors, because you are drawing one vector and then you put the tip of that vector at the tail of the second vector. It doesn't matter which vector you choose first. If you drew vector b and then drew vector a, you would still arrive at the same point. I can show you how that works. If I simply draw vector b, so I should put a few tick marks here. So I'm going -2, -1. So here is vector b. I draw vector b first, and then I draw vector a. So I need to go 3 to the right. So 3 to the right, and then I need to go 4 down, and I end up at exactly the same spot. Notice that if I draw vector b first and then vector a, or vector a first and then vector b, I still end up at the exact same point, which is where vector c would point to. This only works for addition. Remember that we had this separate way of doing it when we did subtraction, where we drew each of the two vectors. We drew our initial vector and our final vector, and then the vector that connected the end of the initial vector to the end of the final vector is what we call delta r, which was the difference between those two. So this is graphical vector subtraction. Graphical vector addition, you use the tip to tail method.